Math friends. So our learning target today is I can review proportions, so everything on unit rate and proportional relationships. So it'll be a pretty long video because we're covering everything in the unit. Now I'm going to work at a pretty fast pace, so go ahead and pause it as needed. Again, this is a review video, so I'm not really teaching the full instruction of each learning target. If you want the full instruction, either reach out to me or we can reset any of your videos. All right, here we go. Keep in mind that rate equals cost and speed equals rate, which equals cost. They all kind of mean the same thing. So to find the unit rate, we just need to know how much it is for one of something. So the cost is $1.19, and that is cost for one can, which is 12, what we call FLOZ, fluid ounces. So this is just set up as a division problem. We're literally just going to divide down here, which the question then is how much does it cost for one fluid ounce? Division. Now it's money problem, so we would want to round to the nearest hundredth. So $1.19 divided by 12. And when we round that, what my calculator is showing is that it's 0.099. And that's kind of a tricky one, but when we round that here, this is actually going to round up to 10 cents. So a little bit tricky on rounding there, but we would call this the slope or the unit rate, how much it is for one unit, one fluid ounce of the grape juice. So as stated up above, that slope is the same thing as speed, which is the same thing as rate. So 360 miles in 6 hours is how much in 1 hour. The trick of this is to simply just divide. So 360 divided by 6 would be 60 miles per hour. 60 miles per hour. We'd call that the unit rate because it's out of 1 unit, 1 hour. So that's the learning target on finding unit rates. The next learning target that we hit was on slope. So we talked about rise over run. All right, so here we go. When I instructed this, what I did is I made sure that you had a strategy of building a rectangle for the data points. If we build this rectangle for the data points, we can see that this is an increasing line. We're putting gas in tank, or we're putting money in bank, so it's going to be positive. And the rise is 2, and the run is 1, 2, 3. So rise over run, or height over width kind of idea, rise over run. Positive, increasing up to over 3. Question 2, what's the change that's happening to this line? There's no change. So the steepness of that line is 0. Not steep, not scary. Steepness or the change is 0. So if we're talking about money in a bank, there's no change. If we're talking about gas in a tank, there's no change. It's not increasing, it's not decreasing. All right, question 3, I'm going to pick 2 data points. I'm going to pick these 2, but you can pick any 2. Just make sure you go to lowest terms. This is a decreasing line. It has a height of 2. It has a width of 2, rise over run, which does reduce to -1. And you could always write that as -1 over 1. So that is the review on reading graphs, rise over runs, finding the slope. So here's a kind of the same idea, but an analogy, a slope analogy. So what is the slope? What does it mean? And what time will the water be gone? So we're talking about the amount of water in gallons over here. And right here, this means that we have a 5-gallon full tank, or full bucket, I guess it would be, maybe. You can see that the line is decreasing over the course of time. Okay. So our first question is, what's the slope? Well, we know it's decreasing, and we just need 2 data points. I'm going to probably pick these 2 because they're at really nice points. So my rise is 1, 2, 3, 4, 5. Cool. And my run is 1, 2, 3, 4, 5, which would have been the same story on any of these. It's that there is a change of down 1 over 1. So my slope is -1. That's my slope. So what does this mean? -1 what? So if we walk it out here, we are saying down 1 gallon per what? 1 hour. Down 1 gallon in 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 1 hour. And right here, we're going to talk about what happens. So what this means is down 1 gallon per 1 hour. Because there's really like a 1 sitting under here for change, the change that's happening. At what time will the water be gone? Right there. It's gone. How much water is left in the tank? 0. So at hour 5, the water is gone. The coordinate there is 5. At the 5th hour, there's 0. It's at 50. There's 0 gallons of gas, or gallons of water, rather. So that's the same learning target on slope, but it's more like application. How does it apply to real world? Still talking about how does it apply to real world. What has the greatest slope? So which one is growing at the fastest rate? Which one is the steepest? You should be thinking A. A is the steepest. It's growing the fastest. We're putting money in our bank. That's the one we want. Winner, winner, chicken dinner. All right. Find the slopes using the formula. So here's your formula here. My strategy typically is to make this table, but it's the same strategy of changing the y's. I don't know how that yellow is working for you. And changing the x's. So if we think of these as xy, xy, we're going to get them set up. All right, I'm trying to move some stuff around here, and in my pen, it's not reading the screen. All right, here we go. We're going to plug them in, x, y, x, y. So we pair them up, -5, 7, cool. -1, -2. So there we have it. If we find the change in our y's first, I'm going to subtract. So it's 7 minus -2. Feel free to put that in your calculator. 7 minus -2 is really a positive 9. And over here, careful on this one, -5 minus -1. This is the change in the x. -5 minus -1. Feel free to put that in your calculator, is really -4. Now, as a math teacher, I really don't like that negative in the bottom, so it becomes -9/4 for my final answer. This is my m, my slope. I still did follow this formula. I just want to prove to you that I did. The y's on top, there's my y's, and the x's on bottom. There's my x's. So I did do that. I just like the table organization a little bit better. I just prefer that method. All right, over here we have x and we have an x and a y and an x and y. I'm going to put those in the table. So you have 2, -6, and -9, -6. And we're looking for the change in the y's and the change in the x's. This is kind of what we're looking for here. So we're subtracting. Now be careful here. -6 minus -6 is what? -6 minus -6 is 0. Oh. 2 minus -9 is 11. So this is equal to a slope of 0. That means there is no change happening at all in the y. The y does not have any change. Go ahead, pause video at any time if you're struggling on that. All right, continuing with 2 more examples here. Then we have our xy's. Remember, they're in alphabetical order. So xy, xy. So that's an easy thing to remember. Just make sure that they're in alphabetical order. So 7, 8, and 7, 2. All right, here we go. Subtract the y's, because that's what the formula says to do, right? It's y2 minus y1 on top. Cool. x2 minus x1 on the bottom. That's what I'm doing. So here's my y's. That's 6. Subtract my x's. That's 0. Ooh, what does that equal? Now I want all y'all to be careful with this one. I want you to actually type it in your calculator. 6 over 0. 6 divided by 0. Type it, type it, type it, type it, type it. And you should see the word air. Divide by 0, air. What the calculator is saying, uh-oh, that is a line that is undefined. It's straight, straight, up and down. It is a super scary line, undefined. You would die down that line. So that is the slope of undefined. That's a vertical line. All right, last problem on this target. X, Y, X, Y. Cool. Here we go. Put them in your table. So we have negative 2, 4, and we have 0, 0. Ooh, that's easy subtraction. So here's my y's first. We subtract. 4 minus 0 is 4. We subtract here. Negative 2 minus 0 is negative 2. Lowest terms, make sure we're going lowest terms. So 4 divided by negative 2 is negative 2. Okay, and you can make those fractions a little bit steeper, like, you know, if you're having a hard time seeing that this is the fraction, that the 6 is actually on top, just make them super steep, like these lines right here. You can kind of make them super steep. Cool. So that's the target on using the formula. So now, the target of kind of combining some skills of writing in y equals mx plus b. All right. So how do you write in y equals mx plus b? Well, you need the m, which is the slope, and you need the b, which is the y-intercept. So I'm going to get the y-intercept first just because it's clean, nice and clean on the graph here. Here's my y-axis. Here's where it hits the red line. So this is going to be my y-intercept. So my equation is going to be y equals some sort of mx. And we're going to say here minus 1 is the b. The b is minus 1. It hits down there. The y-intercept or y-intersection. So now I'm going to go get that slope. So I have this nice graph here, so I'm going to go ahead and read it off the graph. It's a decreasing slope. It's negative 1, 2, 3, 4 over 1, 2. So 4 over 2, negative 4 over 2 is negative 2. So the slope of that line is negative 2x. So when we say, what's the equation? This is your final equation here. Y equals negative 2x minus 1. The x and y state variables in the equation. All right, we're going to work the same situation over here, recognizing that this is the y-axis, this is the x-axis, and this is at negative 1, negative 2, negative 3. That right there is the place that it hits. The intersection is at negative 3. It's really at the point 0, negative 3, but we just use the y coordinate there. So find the slope then. So my equation then would be y equals some sort of mx minus 3. So when I find my slope here, it's going to be positive. I can see it's a positive slope. The rise on that is 1, and the run on that is 4. And 1/4 doesn't reduce since it is a prime number on top. So my equation, right, the equation would be y equals 1/4 x minus 3. So that's your learning target on y equals mx plus b. Now, the next learning target is on proportionality, whether something is proportionate. And the key to something being proportionate is it has to go through x, y, 0, 0. So the x has to be 0 and the y has to be 0. So the trick is this, making sure that it's in the form of y equals mx. So solve for y. And just make sure that it's just a y equals mx. So this one's in good shape. Y equals mx. Perfect. Is it proportionate? Yes. The reason being is there's no plus b. This needs to be 0 to give us a yes there. So we were a-okay on that question because the b is 0. So y equals mx, boom, that's yes. The graphs are super easy to see. You just have to see if it goes to the origin. Now here's the origin because here's the y-axis. Here's the x-axis. Does the black line hit the origin? No. Question 3, in this particular case, it's super easy to see 0, 0s in the table, but sometimes that doesn't happen, where you can't really see what's happening around the origin. There's a bunch of data points, but you can't see the data points. So a good strategy then would be to graph it. So put these data points on the graph, left 2 up 4, left 1 up 2. You can just kind of follow along, watch me on that. 0, 0, 1, negative 2. Graph it and see if it goes through the origin. Now, obviously, this one said right there that it was going to go through the origin, so it's a yes, but graphing is always a good strategy. Question 4. Our job is to get it in the form of y equals mx, as we did here. And if we have a plus 0, or just a y equals mx, it's a yes. So let's see what happens when I solve for y. I'm going to subtract 3, copy, paste, copy, paste. Now the left-hand side is unlike terms, so that's x minus 3 equals y. So I'm going to rewrite that. I'm going to move this over here. I'm going to flip them around. So that's y equals x minus 3. And the dilemma we have on this one is we have this minus 3 here. We have a y equals mx. We have the y equals mx, but it's not proportionate because of this right here needs to be 0. So this is a no. Okay, and the last one here. Here's the y-axis. Here's the x-axis. Here's the origin. Does the line hit the origin at 0, 0? No. We're always checking 0, 0. So that's your learning target on proportionate. Whether it's a graph, equation, and a table are proportionate. The next learning target is setting up something in proportionality. So last month you purchased 2 apps for $9. So I'm seeing apps in dollars. 2 apps, $9. Write and solve a proportion for this month. If you purchase 3 apps, 3 what? 3 apps for what? How many dollars? Taking cross products and solving then. So we're going to multiply these and multiply those and solve for x. Again, this is going at a fast pace. You just need to push pause. So we have 2 times x and we have 3 times 9. So 2 times x is 2x. 3 times 9 is 27. We're going to divide both sides by 2. We're looking for dollars here. How many dollars does it cost? Let you catch up for a minute. My calculator says 13.5, but we're really talking money, right? So we have to be aware of that we're going to need to put that placeholder in because it's a money problem. So the problem is saying that 3 apps cost $13.50. That's the answer we're looking for. That's the value of x. Continuing with proportional word problems. These ones are a little bit tricky sometimes for kids, but once you've seen a few of them, you get the hang of it. But red paint to blue paint is 3 to 5. So you just read that in order. It comes in order. Red paint to blue paint is 3 to 5. Just read it in order. How many red paint or how much red paint would you need? That's a poorly written question. For 30 parts blue. Where do I put the 30 parts blue? Ah, under the blue. So the question is how much red paint? So take cross products to solve. We're going to multiply these 2 and we're going to multiply those 2. So when we multiply x and 5, we get x times 5 or 5x, either way. When we multiply these 2, we get 3 times 30, which is 90. We're going to divide both sides by 5. Division, copy, paste, copy, paste. You'll notice I switched the order around there. I did that on purpose just so that you could see a little difference in order. Doesn't matter. It's commutative. 18. 18 what? 18 red parts to 30 blue parts because we were solving for the x, the red parts. So this is a coordinate. That's an ordered pair, a relationship to mix the paint correctly so it stays proportionate. So it doesn't look like a different color than it's supposed to be. Another word problem. The Skyhawk school color is made by mixing blue paint with white paint. Very similar question. So I'm hearing blue paint with white paint. The ratio of blue paint to white paint is 4 to 5. Blue to white, 4 to 5. How much blue paint should be mixed with 10 ounces of white paint? How much blue paint for 10 ounces of white? Taking cross products to solve, we're multiplying these, multiplying those. So that gives us 5x equals 40. Division is the operation, so we're going to divide both sides by 5. We get x equals 8. 8 what? 8 ounces of blue paint mixed with 10 ounces of white paint. That's the coordinate that we're filling in for because we just solved for x. Proportional word problems. 2 Japanese monkeys get, so I'm going to stop. 2 Japanese monkeys. I guess I could have put monkeys. I'm going to undo that. Got a mess there, you guys. Monkeys. 2 Japanese monkeys get 0.5 kilograms of biscuits. So 2 monkeys, this many biscuits each day. How much would 7 monkeys, where should I put the 7? 7, 7, 7. Oh yeah, under the monkeys, get each day. How many biscuits? Taking cross products then, so we're going to multiply these. Whoops, I didn't really need the crayon, but that's okay. multiply those. So we multiply those together. What happens? I like to start with the variable first. Let's 2x equals, multiply 1/2 of 7. So 0.5 times 7, do it, is 3.5. You should be pushing pause. I warned you about that. Division is the operation. Divide, copy, paste. Or you can watch it for a minute and then rewind it back and just let it play out, see what happens, and then rewind it back. So you can give it a try. 1.75 kilograms. So 7 monkeys have need 1.7 kilograms of biscuits. So now proportional relationships in what we call in math similar figures. The question says determine the height of the lighthouse. So how high is the lighthouse? I'm going to move down just so I have some space. All right. And I like to call these like the small figure and the big figure just so that there's like always a consistency on what we're doing. All right. So the small figure is the number, we have the number 8. That's the height. And that goes with the big figure height of h. So 8 and h go together. We call that corresponding. In the small figure, it's 2.5. So these two numbers came from the small figure. That's the width of the lighthouse, and that would go with 10. So these two numbers go together, and these two numbers go together in terms of they're in the same spot. So we take cross products and solve. So we get 2.5h is equal to 8 times 10. Cross products. Well, 8 times 10 is really 80, right? So I'm just going to go right to this next step. So that's 80. I can use my calculator. I'm going to use it anyway. This is 2.5. I'm going to go ahead and just rewrite that because that's a bit of a struggle right now. Whoops. Come on. All right, cool. So we get h is equal to 80 divided by 2.5. Gives us 32. Now we don't know the units, we'll assume feet. So the height is equal to 32. The height is 32. All right, determine the height of the car. So we have this unknown height of car. I think I forgot part of my picture here. So we're going to call this number over here 3. I'm not going to be able to complete the problem. I'm not sure what happened. Small, big. In the small figure, the height of the car is 3. That matches the height of the other car, which is h. The width of the car is 5. Now all of that, it comes from the small figure. The width of the car 5 goes with the width of the car 12. Corresponding, we call it corresponding. Now don't be surprised if you get a decimal on this one. So we're going to multiply there, we get 5 times h. We're going to multiply there, we get 36. We're going to divide both sides by 5. We're looking for the height of the car. So the height would be equal to 36 divided by 5 is 7.2. And again, we don't have units, so we'll just go ahead and assume feet, but 7.2 is the units on the similar figures. So here's another example of what is the height of the tree using similar figures. Okay, so some things to point out here, that we do have a small and we do have a big, okay? And I'm going to kind of separate them for a minute so you can see that there's the small and here's the big. So the small is super clear, that the small is 3 and 4. We just have to match them up. There's the small. Okay. So it might be easiest for you to see that the 4, it goes with the height of the tree or the big. So the 4 and the h go together. The 3 goes with the all of this. 3 plus 8 is 11. So the 3 in the small goes with all of that in the big. So we're still going to take cross products and solve. We're looking for the height of the tree. So we're going to take cross products here. So we get 3h equals 44. We're going to divide both sides by 3. And we get H is equal to, and we're looking for feet here, 44 divided by 3. It's a repeating decimal of 14 point, and I'm going to cut it off to 7. Or you can do a repeating decimal of 66666 with a bar, right? So like this is fine too. And we're talking the unit is feet. So that is the height of the tree using similar figures. All right, guys, so that is the unit on proportional relationships. That covers everything in this unit. Please reach out if you need help. Good luck on your test. Have a glorious night.